Right, guys, before we look at the graph of the inverse tan hyperbolic, let's briefly discuss the graph of tan hyperbolic. Remember, tan hyperbolic, yesterday we got an expression for it, it was equal to what? Tan hyperbolic of x. Do you still remember the expression? You have got it in your books, no? What is it? e to the power of x minus e to the power of minus x divided by e to the power of x plus e to the power of minus x. Right. Let's just discuss. I don't know if it's going to be easy to follow this, but I'm going to try my best to make you follow it. Just check something here. These two functions, this one, when x or the absolute value of x is very high, it's a very big number, this is almost 0. This is approximately 0 when x is very big. You understand what I'm saying? When x, let's say x is like a big value towards infinity, this is approximately 0. Now, but if we ignore, let's ignore this term for a while. Just ignore this term for a while. What do you expect this quotient to be? Do you expect it to be more than 1 or to less than 1? More than 1 or less than 1? More than 1. Is it? Because the numerator is smaller than the denominator. Is it? This e is there e. If it was e over e to be 1, but it is e and plus something, even if it's small, then the denominator is bigger than that, so it's less than 1. Is it? Okay. Let me just draw a sketch there. Then 1 becomes a very interesting number here. Let's say we've got 1 there, and we've got minus 1 here. Let's just draw a line of some kind here, a horizontal line, across 1. That is the line y is equal to 1, and that is the line y is equal to minus 1. Okay. Then also, let's roughly reflect on our graphs. This is cos hyperbolic. This is sine hyperbolic. But this is a division of sine hyperbolic and cos hyperbolic, isn't it? Now, 0, the origin is here. Let's just look at what happens on the right hand side of the origin. On the right hand side of the origin. Is the quotient going to be positive or negative? This quotient of cosine and the sine hyperbolic, is it going to be positive or negative? Think, guys. The value of cosine is somewhere there. The value of sine is somewhere there. If I divide these two numbers, it's going to be positive or negative? Positive. But at 0, tan hyperbolic at 0, what is it? Is 0 here? 1. 0 there is going to be 1. Then it's 1 minus 1. But there is going to be 2. So which means at 0, the function passes through 0 there. But this side is positive. What's going to happen on this side of the left of origin? We'll be dividing this value there with the value somewhere there which is negative. Y is there negative, there is positive. So how is the function going to be decided? Negative, isn't it? Okay. Now you'll see that this function actually will grow steadily from here. But it never touches 1. So that line becomes an asymptote. Then this side, it decreases steadily, and the asymptote, have an asymptote there, a line y is equal to minus 1. That's what it's going to be. Now to think of the inverse graph of this function, imagine your y is equal to x line going there, and then reflecting this across. Obvious. If we're going to reflect this across the y-axis, it means the x also is going to be reflected. Where is x going to go? X is going to land here, isn't it? So these lines which are horizontal, they're going to be vertical. So the resulting graph there is going to lie between -1 and the 1. And it will look like the usual tan graph, isn't it? More or less. But the tan graph, remember, is between -pi and pi, I think. But this one, shape looks like similar to it, but between -1 and 1. Then that's the graph start. All together. So I think with that, you can now make sense of the graphs of these functions as you see them in the book. I don't know. What do you think? Another question? Yes, my brother. Okay. All right. So maybe let me stop this one there. Then we'll continue with our exercises, practicing equations and the problems related to this.